Okay, I'm going to show you how to get started on a PIC32. I'm going to use the new graphical configuration tool, which is called Harmony. And that's the way I would suggest you do it. I don't normally do this. This is new for me, but I think that, since you're learning, that would be the thing to do. So I click under New Project. I want a microchip embedded. It's going to be a 32-bit PIC. I hit select that, hit next. Sometimes this directory may have to be changed. Harmony is in addition to the MPLAB X, so you need to go back to Microchip and download the Harmony program. And when it installs on my machine, it installs on the C drive. Let's see if I can find that on this PC, the C drive. It gets installed on Microchip Harmony. I only have one version installed, so you select that one and say open, and but that was already there. Project location. I don't like to put it in the Harmony drive, but what you can do is maybe put it on, probably the Dropbox or something. I'm going to put it on the C drive. I'm going to create a new directory. We're going to call it New Project. But again, you should probably want to put this on the Dropbox or something. So you select that and say open. Project location is going to be in the project. The project name is a program. So I think that goes with everything. Down here, the device family, EMX. Over here, select the chip that you're using. The one we use is down at the bottom. Oh, okay. Should probably, it's the MX. And then it's at the bottom here. There's a whole bunch of them, but anyway, you select the one, so boom, you get that guy. Let me pull over the file directory listing. This guy called New Program. Where did I put it? Let me pause it till I find. Okay, all I did was refresh the screen. You can see this new project was here. Here's your program, and it created all the rest of the stuff in here. So here's some source files, and all the way down. Anyway, so that's in there. All right, so it's done that for me. Okay, so we're back over here. One of the first things that you have to do in this is to configure the clock, right? So we'll come back to the options here in a second. The clock has a diagram here, and this is the tells you how fast the processor moves, or how quick, how it runs. Okay, whatever. All right, and this is relatively complex, and that's one of the issues, is that if you're not familiar with it, it's just too many things to try to adjust. This diagram right here, this file, you can get it from the web page. It's basically the data sheet for the PIC32 that we're using, and in here it will have things like the clock. Where is it? Oscillator. So, I call it clock, but it's really an oscillator. And if you notice, this diagram here that's in the documentation is basically the same thing as what they show over here. So this is a graphical thing. These words like this up, PLL, divide, all of that, if you search in this data sheet for that word, well, let's take this FPL business, okay? So if you search for FPLLIDIV, what will happen is you will see it here. Search again, and right here. Okay, so it tells you, let's see, I think I lost it. All right, so right there, FPLIDIV. is in the memory location DEV CFG2, and it tells you on this next page what what happens. So if you put in a 100, it's going to take this and divide by 6. So that's how you know what it does. But now with the graphical thing, you don't really have to worry about it, because what you'll do is you put it, put the values that you want in here. So you'll say, okay, I'm gonna maybe select this guy. Okay, I need to select something else here in a second. But what you do is with this graphical thing, you select what you want it to be, and then it will adjust it. So right now, for example, the system clock is going to be running at 40 megahertz, pretty fast. All right, so let's see. I'm going to pause till I figure out what's happening here. Okay, I figured out what the issue is. Let's go back here to the options, which I was going to ignore for a little bit. Okay, so the chip has a configuration. You can see here, and it's purple because I've been screwing around with it. Ordinarily it'd be black. It would take the defaults. But what I would do is so you click on here. Configurations are things that you typically will set on the chip one time. When it's programmed, they set these things, and they're not changeable once the thing begins to run. When you reprogram it, it can be rewritten. So these things can be changed, but they have to be changed by the programmer. As far as I know, it's not possible to change these in software. And essentially there's four. There's a device configuration 0, 1, 2, and 3. If you want to know what those things are and a description of them, they're over here. And somewhere in the configuration, there's something over here, and this guy will talk about the configuration. Anyway, so that's where you would find a description of what they do. But anyway, I've expanded these, and some of them, make sense, I think. So, for example, the boot flash is where when the power comes on, the program begins to run at that. Flash is called, they call it flash. It's non-volatile memory. It's basically read-only memory. You program it once and off you go. And so you can say, I want to protect that so that people can't change it. Right? And so boom, it's, I don't know why you'd want to do that. Typically once we get into production, we turn all those things on. The watchdog timer, I think you understand what that is. That's adjusted here. You can either turn it on, or you say, well, I don't want it on, or whatever, right? So this is where you would decide what you want. Now, what I changed was the oscillator selection, because I wasn't able to change anything on the clock diagram. And so here is all the different clocks that you can run this thing on. And where do you find information about that? Well, it's found over here. So, in the oscillator configuration, if you zoom in on this thing, you can read about it. And it says, well, there's different ways that you can, set up the, the different clocks of this. A primary oscillator is from outside, so you can see right here, these are pins that come in right here. I guess right here is the X. Those are pins that come in from outside, so you can run it from some external clock. That's the way it used to be done. And then you have inside, you have a FRC, fast RC oscillator. It's a resistor capacitor. It's built in. And you can select that one as well. Or you can run on a low power resistor capacitor oscillator, LPRC. And so it comes in at some, frequency. So those are the clocks that you can configure. So, that's what's selected here. PLL is a phase lock loop. It's some electrical way of making clocks run faster. You basically have a lower speed clock, and you divide it up into different speeds. I typically use the FRC, fast RC, so it's inside the chip. With a phase lock loop, so you can select that one. If you don't, you're not able to, if you select this guy and then go to the clock diagram, see all these are grayed out. You can't change them because this is the phase lock loop business. So it's coming in here, and you're stuck at whatever the frequency is. So just to show what you can do. Okay, let's select the FRC phase lock loop, and then when you go over here to the clock diagram, all these guys are now selectable, right? This one, I guess that one's selectable too. Okay, so anyway, right now the clock speed is at 80 megahertz. I think that's 80 meg. I'm not sure how many zeros there are. I think it's 80 meg. Typically the FRC comes in at 8, and so what you do is if you read the documentation, the phase lock loop input has to be lower than what right here, if you pause over this, it says the frequency input needs to be between 3.98 and 5. So you can't do this. You can't go in here and divide by 1, because now see it's red. That's an error. You can't do that. This guy won't run that fast. So what you do is you divide it down, right? You could make it, I don't know why you wanted anything else, but anyway, so you got 4 going in, which is good. And then what you're going to do is you're going to multiply it by, say, 24. And you see how the output changes, or whatever, right? I don't know why, but I tend to run. What did I have it at? 20 maybe? I don't remember. Anyway, I tend to run them at 80 megs. I have no idea why. The faster it runs, the more power it consumes. And then you can divide it, I don't know why you'd want to do this, to be honest. I'm sure there's reasons, but you can see, what you're doing, and we'll put it back. Okay, so it's going to run at 80 megahertz. So that's how quickly it's going to do each instruction. And then you have a peripheral bus which controls your A to D and all of those, and sometimes you want those to run slower. Again, I don't know why, but if you did, then you would come in here and say, well, I want the peripheral to run divide by 8, maybe divide by 1. See, the peripherals now run the same speed. I can check and see. For some reason, I always run it at half the speed anyway. So that's what you're doing here. And what these things are doing is basically changing the values the values that go into the actual memory location that sets up the clock so it runs. So that's what this is graphically doing. Okay, so a lot of this stuff I have no idea what it is. I just leave it at the default. The secondary oscillator is typically used, let's say you're doing something high speed and then you're going to go to sleep, or maybe low power. So you can set up a secondary oscillator if you want to, and if you do, then you'd adjust it here, and then you can switch back and forth between the high-speed oscillator and the low-speed, low-power oscillator. So I think you get the idea. Most of the time, you'd leave this alone. But one of the things I want to show you is if you click on this pin diagram right here, these two guys are green, so they're already being used. They're being used for the secondary oscillator. I don't know what SCO is, but and the reason those are there is because it's right here. If you come over here, let's see, secondary oscillator enable, you're going to turn it off. So I'm not going to use the secondary oscillator. If you notice that every time I click on something, this little window over here opens up, which is giving you some information about what you're clicking. Now, if you go, I turned off the secondary oscillator. If you go over to the pin diagram, whoops, no, let's see, oscillator enable. I'm going to disable it. Go to the pin diagram. See, they're no longer configured, so those pins are available now. But if you say I want to, right, you can see that these guys are coming from outside. If you're going to use the secondary oscillator, then it requires those pins, and so you can't use them for anything else. Okay, so I think you get the idea. So typically, if you say, well, what configurations should I use? Well, we can take a look at the stuff that we've done before. So like over here, like I said, most of the stuff I just leave alone. But anyway, okay, so you set up the clock so it will run at a certain speed, and then you come over here to the pin settings, and what you'll do is you'll come in and say, well, you know, for this pin, pin number 20, I would like it to be in digital instead of an analog. Pin number 21, I want it analog. So I think you get the idea of what you're going to do here. In addition to that, some of the pins have what they call a change notification. So in other words, when they change, it will create an interrupt so that you're aware of it. So you would use this for like a zero crossing for the AC or something. So if you want that, you would select that there, and it says, oh, okay, then the function that's on this pin is a change notice. If you don't want that, then you clear it, and off you go. In addition to, you know, if you notice, I think all of the change notices also have pull-ups, and I think you know what a pull-up is. So it has a built-in pull-up. If you want the pull-up energized, enabled, you select here. Otherwise, you'd leave it off, right? Whatever you want to do. And so now, you know, like for example here, oh, I want this to be an output. I want this one to be an output, whatever. I don't think you can type a name in here. I'm not sure. Nope, I guess not. Open drain. Basically, these outputs can either push current or suck current in. Open drain means that it will not be able to push current, but it is able to suck current in. It's kind of, you know, rare that you would want to do something like that, but you can. So you know, energize that guy if you want. So that's what this is. You know, you're just setting everything up. And then once you set your pin settings, I think if you hit this save button, I think this little star will disappear. Let's see, save it, yes. No, oh yeah, there it disappeared. Okay, right. So if I go in there and change something, then I don't know what to change. Okay, we'll make it priority 0. Yeah, see, it comes back. So let me put it back to 7. That's you know, we can talk about that anyway. Okay, so I'm going to save it. Boom. All right. And then after I do that, what I'm going to do is I'm going to generate the code. Boom. So I generate the code. I really haven't read this too much, but anyway, so I generate the code. Bam, bam, bam. It's done. And then what I'm going to do is show you what happens to the code, right? So in the directory, this is a program, and then, you know, go all the way down to this thing. Okay, here's what, maybe it's better to show you over here. Okay, so what's happened is it has created some source files for me. Framework is just a fancy name for basically what happens is there's two ways of doing things. One is that, like what I've always done, you write a main program, and the first thing you do is configure everything. You set up the clock, you set up all these other things, and I'll show you some of that. And it tends to be real short code because you're doing exactly what you need to do for this chip and nothing else. A framework is more like what Microchip would want people to use, right? They have a framework that you say, I want to set the clock. Well, everybody has to set clocks, but exactly how you do it depends on which chip you're using. So what they do is they try to write general code that will work for all of their chips, and it's just kind of a standard way of approaching things, and they call it a framework. Okay, now if you notice, it's got all kinds of crazy you know, things in here of the framework, right? And so basically what's going to happen is all of these C files in here are things that are written by them, that if you use them and don't change them, you are supposed to be able to, when they make a change or whatever, you know, you'll be able to use the stuff that they write. So basically that's a, you know, it's just kind of a complicated, but it gets relatively complicated. But anyway, so here we go. So you know, all of these files here that I'm expanding down, those things have all been written for us. And you can see that, you know, they're just, you know, why do they have so much? Well, it's because they're trying to, you know, write code that is good for every chip that is, you know, that they do. Okay, so all of this stuff is created by Harmony. What's important to us is, and there's also header files up here as well. So there's all kinds of header files and stuff. Okay, now the things that are important is that there's a main program. Everybody has a main. You don't change this. This is a kind of a standard main program, so you don't really mess with this, and all of these things that are being included are being included because of the framework. But in the main main program, one of the first things it does is it does a system initialize, a sys initialize. I'm going to highlight this, right click, and then navigate to the implementation. So here is what sys initialize does. What does it do? It initializes the clock. I don't care how they do it. I just trust that they did it from Harmony. But if you wanted to go to the implementation, here's what they do. They unlock the clock. They then set the divisor, and they, all of this, and then they lock the system back up so that nobody else can change it, because you don't want the clock changing on you. Okay, so that's what happens. So system initialize. We'll go back here. Performance configuration, I have no idea, but that's what it's, it's going to initialize something. And then there's an application initialize. So if you go to the application initialize, what does it do? Well, here's the, if you notice it's in the app.c. This is the application. All right, so notice right here, they're telling you to initialize your application in whatever you need to do. So the APP is where you put your stuff that you want to do. Everything else is taken care of for you. So you don't modify the main. It initializes everything. And one of those things is going to call your app initialize. So when you look at your Arduino and it has the, what is it, setup or something, that's basically right here, app initialize, that's your setup. You're going to put all of the stuff that's done one time right here. Okay, so you do that. Then in the main program, if you notice, what it does is it then, after it initializes everything, it goes into an infinite loop right here, through here. It goes into the infinite loop. So that's your loop, corresponds to the loop. And all it does is it goes in here and calls you, just over and over and over again. It just calls you right here, system tasks, right? And the system tasks is going to do whatever they know they have to do, and then it calls you right here, app, right? So if you go to the app.c, so here's the app.c, right? And we'll scroll up, blah, 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 text, text, text. It includes your app.h, okay, which we can talk about. I don't know what the app data is. We'll take a look at that in a little bit. And then here's where you put your initialization stuff. And then here's your tasks. This thing is going to be called over and over and over and over and over again, right? So it just constantly, after it sets up, initializes, then it just calls you over and over until forever. And then so it gives you some basic ideas. So you could wipe all of this mess out right here and just put in whatever you want, and then that is your loop that corresponds to the Arduino. Okay. Most of these files over here, you just don't mess with. You just trust that they've got things working. And so what I would do if I were you is right here where it says app tasks, I would just call Mike's program, and then something like this. So it'll do Mike's program, and then have a separate file over here, in the source files called Mike's program.c, and then put everything in there, because this thing, this app.c, whenever you run Harmony, it's going to create a new app.c. So I would put in one thing that, only one change, so that if you ever create a new app.c, bam, you only have to edit this thing just a little bit. And here, just put in something, like this, Mike's initial, something like that, right? So that there's only two changes that you've made to app.c, and then everything else goes in Mike's initial.c and Mike's program.c, so that that would never change, and Harmony never messes with it. And then, of course, when you're done, you save it, and then you should be able to compile it. It's not going to compile. Let's get rid of this guy there and there. Okay, so then we should be able to compile this thing without any errors. So there we go. And boom, everything compiles. A lot of mess, right? But there you go, done. And so that's how you would start. Okay, hopefully that helps. And if you need, like I said, if you need help with what's in the the options and stuff like that, we'll dig it out of the our other one. I'm going to pause now. Okay, what I've done now is I've opened up the codes that I've written before. The bootloader, that's the stuff from the Evo Air. And and all of this was done without Harmony. This was before they had Harmony. And there is, these were all written, but if you look at this one in particular, interface.c, this guy has the main program in it right there. So here's the main program that was written. And what happens? Well, it sets up some variables, but then what it does is it initializes hardware, right? So it's very similar to what you've seen already, right? So if you go to the implementation of this, initialize hardware, this is where it is, right? It's in a program called, well, it's in the interface. And what does it do? It, let's see, it disables interrupts. Okay, we can talk about that. This task intercritical, that is because we're using the real-time operating system. And so this is a critical thing. Don't interrupt us while we do it. This initialize pins sets up, who's analog, who's input, who's output, all that sort of thing, which, the Harmony does for us. And then we initialize the clock. So if you look at how you initialize the clock, go to that one. Here's how it initializes the clock. Well, these guys, oscillator control, right? That is over here. Here's the documentation. So if you look for oscillator OSCCON, boom, there is a memory location called oscillator control, and one more down, nothing found. I don't buy that. Okay. Oops. Okay, well, I guess it's here. So in the oscillator control, there is a PLL output divide and those things. So that's where in the old days, what you had to do is you had to figure out what number to put in there. This is all generated with the Harmony right now. So there's probably no reason that you want to even remember this, because no way do you know what this is, right? You'd have to pull up the documentation and figure out what the heck is a PLL mult. But anyway, I think you get the idea of the relationship. So all of these things, we used to do the same thing all the time, right? You'd initialize the clock, you'd initialize your pins, and then LCD, you'd initialize the LCD, the UART, which is a serial communications. All of that stuff was done in here, and it's just taken care of with Harmony now. So, but we used to have to do it all by hand. Okay, that's it. I'm going to post it.